Hello everyone, this is Mritul Agrawal from SWAITTLLP. So the problems that we are trying to solve is based on the lead acid based e-rickshaw. It is having a limited range of only 100 kilometers. It is having limited life of 1 to 1.5 years, and it is having a longer charging time of 9 to 10 hours with limited passengers of only 4, and there is high maintenance requirement for a lead acid battery. And there is also no standalone charging possibility at remote locations when we want to run it for a longer range in a single charge, and it's also toxic in nature. So the solution that we are projecting is a solar powered electrical vehicle whose design is as shown below. The layout of the solar powered electrical vehicle is shown here, where we have PV panels and the battery which is integrated through the MPPT controller to the motor controller and to the BLDC motor, and finally to the differential gear, and it is able to run this motor in a way so that it can cover a longer range and have lower charging time as well. So the solar powered electric rickshaw will have the various benefits, like it's using lithium ion battery which is less toxic in nature. It can run for 4 to 5 years. It is having a smaller charging time of only 3 to 4 hours, and the range that we are projecting is around 150 plus kilometers for a single charge, and the charging cost is also low because we have to charge it for a smaller time, and the weight of vehicle is also low since the solar powered electric vehicle has a lesser weight, and it has a lesser disbalance condition because of its four-wheeler based design. So currently we have designed the individual component, we have done the calculation for the SPV as well, and now we are trying to integrate all the individual components and trying out to identify how the observational parameters would change if the electrical specifications are changed. And now afterwards we would be integrating wireless technology as well if possible on ground. So the analysis that we have done is shown here. This is done using various sensors and ultra software. This is the proof of concept. You can watch this video now.
So hello everyone, this is Mritul Agrawal from SWAITTLLPF. So currently we are testing out the electrical connections of the solar powered electrical vehicle, in which we have 4 batteries like this one. These are the 4 batteries. Each battery has a voltage of 12 volts, and it is completely making a 140 Ah battery backup. And this is connected to this MCB to solar charge controller. This solar charge controller is able to furnish the power to the motor controller, and this power is being fed through the motor, and we have various safety devices in between. We can practical now. So now integrating the solar PV panels to the solar charge controller. In the next part,
So the financial analysis of the EV versus SPV that we have done, we have found that for an initial increment of around 20,000 in the initial cost, we can have a yearly cost of energy purchasing going down from 18,000 to 6,000 around, and the annual revenue increasing from 7,30,000 to around 10,95,000, and this is projecting saving at the end of first year to around doubling from 3,30,000 to around 6,90,000. So this is the projection. So we would be finding out the actual cost and the actual benefits in the cost as well after we are done with the prototype. So if you have any queries, you can ask. Thank you.